In this problem, we are solving for a missing side. We are looking for side AB, and if you look at where AB is in this diagram here, it is opposite of angle C. So I'm going to go for the label, instead of AB, I'm going to call this lowercase c. It just kind of streamlines with what we've studied as the law of sines, but hey, it's a preference thing at the end of the day, and I prefer lowercase c. Okay, so I'll make a little note of that as I'm looking for lowercase c. That is side AB. Now, as we get started here, since we are looking for a side, again rounding to tenths, we are going to choose one of the law of sines versions here that'll serve our purposes best. Technically, we could choose either one, but I said or here because if you're solving for a missing side, you want to go for the version of the law of sines that has the missing side or the sides on the top. So I'm going to go and use this version this time, and we can set up these ratios. All right, so as we get started, we know we're going to be looking for side C. And so I put side C over sine of its corresponding angle. Whoa, 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 whoa. What's going on here? We don't have the angle. Well, we actually do. This is kind of a side problem. When you have two angles given in a triangle, we get to cash in on the triangle sum theorem that says angle A plus angle B plus angle C all have to add up to 180. So if we do a little subtraction, we can find that angle C is just 180 minus these other two angles, so minus 98 and minus 45 degrees. So that's, what is that, 180 minus 143, which would be 37 degrees, I believe. Okay. So angle C is findable. That is 37 degrees, but it took a little bit of thought to get that from the triangle sum theorem. Okay, back on track. We have side C we're looking for over the sine of its angle, its corresponding angle. And the other thing that we know is 98 degrees and 15 are also corresponding pieces. So we could build a ratio out of that. So I'm going to set this equal to 15 over sine of its angle 98 degrees. Okay, now we've got the setup. We've got one variable. So I'm going to solve for C now by multiplying both sides by this sine of 37. The reason I'm doing that is, of course, I want to get C by itself. So in order to undivide C by sine 37, I need to undivide, aka multiply both sides by sine of 37. All right, so that'll reduce nicely right out of the bottom here on the left side, and now we just have C isolated, and we'll go in and calculate C equals 15 times the sine of 37 degrees divided by sine of 98 degrees. All right, I'm sorry, I've realized that in these videos my calculator app doesn't show up on the screen, or not at least the way that I'm using it. So I'm going to just do this on an off-screen calculator here, double checking that I'm in degree mode. 15 times the sine of 37 divided by sine of 98 degrees. And we get a value here of 9.11, but it says to the nearest tenth, so I'm just going to say 9.1. Now, before I hit submit on this, I want to check just the side lengths. So is 9.1 a suitable, as you look at your corresponding angles, 37 degrees, should that have a side length that big? And with 98 paired up with 15, 98 is clearly the biggest angle, and 15 remains the biggest known side. So there's nothing wrong with the intuition of 9.1 being the right answer here. All right, I hope that helped.